cultures have their own creation myth, so most also have their own take on how the universe will end. In the 11th century, the ancient Norse myth of Ragnarok predicted that the universe, and time along with it, would end in a desperate battle between the forces of good and evil. It was believed that this apocalypse would be preceded by something called the Winter of Winters, an epic ice age, during which all the stars would gradually vanish from the sky. How the universe will end continues to preoccupy us over 1,000 years later. In 1988, physicist Saul Perlmutter joined this quest to discover the fate of the cosmos.
It seems like a really philosophical question. Is the universe going to last forever, or is it someday going to come to an end? But in just the last few decades, we finally have both the intellectual tools that Einstein gave us and the practical measurement tools.
Saul believed that the destiny of our universe was linked to the rate at which it was expanding.
Since the 1930s, we've known that the universe is expanding, and everybody's understanding was that it would be slowing down in that expansion because all of the stuff in the universe would gravitationally attract all the other stuff, and so it would slow the expansion down little by little.
This would result in the universe collapsing back in on itself in something called the Big Crunch, bringing time to an abrupt and violent halt.
Are there any decisions coming up? Are there any other ones that we're actually going to have to decide something about?
To discover just when the universe and time would end, Saul and his team began to hunt for extremely rare objects known as supernovae,
And remind me, where would
the aftermath of exploded stars.
There are two things you need to know about a given supernova once you discovered one. First, its peak brightness. That tells you how far away it is, and hence how far back in time the explosion occurred. The other thing is you want to look at its color through its spectrum. And the more it's been shifted to the red, it's called redshift, the more the universe has stretched since the time of that explosion.
Painstakingly, Saul and his team began to discover one supernova after another.
After several years of the supernova hunting, we had built up a sample of some 42 supernovae, and we were finally ready to go back to ask that question that we began the project with: what is the fate of the universe?
But the answer they came up with came as something of a shock.
When we finally graphed the results, we found a very surprising result. Apparently, the universe is not slowing down. It was actually speeding up, and that was the big surprise.
In other words, the universe wasn't headed for a big crunch at all. So what will its fate be? Saul's discovery has helped scientists to map out how time and the universe will evolve. An incredible space epic separated into 5 long ages. The first of these was the primordial age, starting with the Big Bang and the birth of time. Lasting only 350,000 years, that's long gone. We're now 13.7 billion years into the second age, and it's only just beginning. We live in something called the Stelliferous Era, an epoch that has brought us not just the stars and the planets, but also every speck of matter in the universe. One day, 100 million years from now, a mere finger click in the life of the universe, this golden age will come to an end. in its place will come the degenerate age, when the last stars burn out and die, when the planets fall from their orbits, and in the darkness of space, matter begins to decay. After a truly unimaginable length of time, only black holes remain. A fourth age that far exceeds all the time that has ever gone before. But even black holes don't last forever. Little by little, their thermal energy will leak away, until ultimately they too disappear.
So what does this mean for the future of time? Does the death of our universe mean that time is destined to run out? Or is time really eternal, without end?
Even as the last black hole evaporates, a fifth and final age is beginning. The age of the photon, in which time finally fragments into total disorder. When all that remains of our cosmos are invisible, indestructible, low-energy, light particles. For Saul Perlmutter, this cold chaos represents the ultimate destiny for time.
This particular picture of the future of the universe, and we don't know if this will be the final answer, would have time lasting forever. There will be no end to the universe in this particular scenario.
As we look out to the vastness of time that lies ahead, we begin to notice something truly incredible. As we move from one age of the universe to the next, we see that the nature of time itself begins to change. Time evolves. Ultimately, the strange and chaotic behavior that we can only glimpse inside the atom may in general become the nature of time throughout the entire cosmos. And if we could somehow hang around to experience it, we might not even recognize it as time at all.
Because just as particles can be in many places at once, so in our quantum cosmos, we might uncover many universes, each one with a time of its own.
So this new perspective of time over the whole life of the cosmos makes us look at our time from a new point of view. The time that we feel passing, the time that we know and trust, may be something of an illusion that allows us to make sense of our place in this tiny corner of the cosmos.